Hi students! Today we will learn about a second type of quadrilateral, and that is rectangle. So let's go back to parallelogram. That's the quadrilateral type that we've already talked about, as well as all of its properties. Parallelogram has his own little family, so I like to call him Papa Parallelogram. One of his first children is the rectangle. The rectangle, it's a special type of parallelogram. So rectangle is going to have all the properties of his dad, parallelogram, plus one extra property that we'll learn. So first let's recall all the properties of parallelogram. So here are the properties of a parallelogram, and we'll see how those relate to a rectangle. So a rectangle was probably one of the first shapes you ever learned about when you were little. You could probably identify them. Some of you may describe a rectangle as like a stretched out square. We'll learn more about squares later, but for right now, let's go ahead and look at the properties that it has gained from its father parallelogram, Papa Parallelogram. So opposite sides are parallel. Okay, they won't intersect. Opposite sides are also congruent. Okay, and I think most of you kind of know that. Opposite angles are congruent. So opposite angles in a rectangle, they're congruent because all the angles are right angles. Okay, so they're definitely congruent. Diagonals bisect each other. That's ugly line. So that means this side and this side are congruent, and the other two sides of the other diagonal are also congruent. Okay, so that's just like parallelogram. And then consecutive angles are supplementary, which would be like this angle and this angle, they would add up to 180. Okay, so those are all properties from parallelogram that you should be familiar with. Now we're going to see what extra property a rectangle has. So in a rectangle, the diagonals, they have a special relationship. So we're going to figure out what that is right now. So we've got this rectangle LMNO graphed on this coordinate grid. It says first name the diagonals. Okay, so the two diagonals are OM and LN. And remember, you can name, you could put OM or MO, that doesn't matter. But then you want to have the segment symbol on top. And then for LN, it could be LN or NL, that doesn't matter. The next thing we're going to do is find the lengths of both of these. So we're going to use the distance formula. So in order to do that, we first need to find the coordinates of the points that we're using. So the distance between O and M, we need to find the coordinates of O and M. So O has coordinates, it looks like -6, -3. So O is -6, -3. And then M has coordinates 4, 4. Okay, and then for Ln, L's coordinates are -6, 4. And then N's coordinates are 4, -3. Okay, so we'll practice this skill. We haven't used it in a while, but we should remember the distance formula. Let's first find the distance between O and M, which would be called OM. We're going to take the square root of, and in the first set of parentheses, we're going to subtract our x's. In the second set of parentheses, we're going to subtract our y's. We're going to square both of them, then add them, and then take the square root. So it's a lengthy process. So for the x's, we've got -6 and 4. We can either do -6 minus 4 or 4 minus -6. It doesn't matter. I'm going to do -6 minus 4. So we're using our two x values right now. And then squared plus, now we'll subtract our y values. So I could do -3 minus 4 or 4 minus -3. It doesn't matter. Looks like I'm going to have to do these one at a time. All right, So now we're going to simplify what's in the parentheses. Negative 6 minus 4 is negative 10 squared, plus negative 3 minus 4 is negative 7. And we'll square that. So now we're going to square both of those numbers. Negative 10 squared is negative 10 times negative 10, which is 100. You should always get a positive number after you square. Negative 7 times negative 7 for negative 7 squared is positive 49. And then if you add 149, you get square root of 149. So that is the length of OM. Okay, square root of 149. So I'm going to write that down somewhere. OM equals square root of 149. All right, now we're going to find the length of LN. So I'm going to erase this work just so we can have some room here. All right. So we're going to do this exact same thing, but we're going to use the coordinates for points L and N. So in the first set of parentheses, we're going to subtract our x values, which are negative 6 and 4. So we can do negative 6 minus 4 or 4 minus negative 6. If you notice, those are the same two numbers we had for the other diagonal's length. Now we're going to add the square of the difference of our y values, which are 4 and negative 3. We could either do 4 minus negative 3 or negative 3 minus 4. It doesn't matter. Okay, now we're going to simplify our parentheses. Negative 6 minus 4 is negative 10, and then we'll square that. 4 minus negative 3 is like 4 plus positive 3, which is 7. And we'll square that. When we square both of these, we also get 149 like we did with the other diagonal. And then when we add that, we also get square root of 149 for the length of our other diagonal. So what I want you to see is that the two diagonals have the same length. Okay, one of the big differences between rectangles and parallelograms is rectangles' diagonals are congruent. Okay, we can say that their diagonals are congruent. And that's why a rectangle is more upright, whereas a parallelogram kind of looks like it's leaning, and that's because its diagonals have different lengths. One is longer than the other, so it kind of makes it lean. So that's one of the big differences between these shapes. So that's the extra characteristics. The diagonals are congruent in a rectangle. So let's go ahead and apply some of these properties to a rectangle and see if we can't find some missing angle measures or missing segment lengths. So this one says in this rectangle, MO has a length of 2x minus 8, and NP has a length of 23. Now these are the lengths of the two diagonals. And we know that the diagonals are congruent. So we can say that 2x minus 8 should equal 23 because those two diagonals are equal. So that's how we would set up our equation. We would just set the two expressions for the two diagonals equal to each other, and then we solve. So we'll add 8 to both sides. So 2x equals 31. Divide both sides by 2. And x equals 15.5. Okay, so it just had us find the value of x. Now, if we wanted to find the length of the diagonals, we could just go back and plug them in here. The other diagonal is 23, so this one should also equal 23 if you plug that in. Let's try another one. So for this rectangle, it says LP has a length of 3x plus 7, and MK has a length of 26. MK is the whole diagonal, whereas LP is half. So in a rectangle, let's go back to our original picture. Because the diagonals are congruent, I really should have, let's see, I really should have the same amount of tick marks in all four halves of our diagonal. So this guy, this guy, this guy, and this guy all have the same length. Two halves equal the whole. So let's go back here. So that LP that's half of the whole diagonal, which is 26. There's a couple different ways we could do this. We could either say, and let me see if I could label my picture a little bit. This whole thing is 26, whereas just this half is 3x plus 7. But we know that all 4 of these parts are congruent. So we could say one of two things. We could either say 3x plus 7, 1/2, plus another half, so plus another 3x plus 7 equals the whole diagonal length of 26. Or we could say 3x plus 7, which is the half, equals half of 26, which is 13. Either of these equations will work, okay? I suggest using the easier one, which is the second equation. But either one you solve, you should get the same value for x. The first equation is just a doubled version of the second equation. So to solve this second equation, we would start by subtracting 7 from both sides. 3x equals 13 minus 7, which is 6. Divide both sides by 3, and x equals 2. There you go. And you could plug it in to make sure that that half does equal 13. Let's do another one. All right, in this rectangle, we have an expression for AC, which is a whole diagonal, and DP, which is half of a diagonal. So this is the half, and this is the whole. And remember, 2 halves equal a whole. So we'll have to say that the x plus 7, that half, plus another x plus 7, or you could do x plus 7 in parentheses times 2 and distribute the 2. You'll get the same thing. That equals the whole thing of 4x minus 13. So this is the equation you would want to start with. Now let's go ahead and combine some like terms. I've got two 1x's. I can combine those to make 2x. And these two 7's I can combine to make 14. Now we'll move our x's to the same side. I'm going to move mine to the right, so I'm going to subtract 2x from both sides. So 14 equals 4x minus 2x is 2x, and then minus 13. Now I'm going to move my constants to the other side, so I'm going to add 13 to both sides. And that makes 27 equals 2x. And then to get x by itself, we'll divide both sides by 2, and 27 divided by 2 is 13.5 for the value of x. So if you looked, all these examples really had to do with the diagonals being congruent or being half of the whole diagonal. Okay, so just kind of be smart with how you set up the equation. It needs to make sense. All right, now we're going to look at the angles. Okay, so those were really the segments, a lot easier than parallelogram because we have a lot of congruent parts. The angles in a rectangle, we need to remember that we've got 4 right angles. Okay, so for example, 7 and 8 are complementary. What I want you to remember, and this is also true of parallelograms, is this angle does not equal this angle. Okay. They're not equal, so the diagonals do not bisect those 90-degree angles. It's not 245s. That angle 8, that's going to be congruent to angle 4 down here, and angle 7 will be congruent to angle 3 because those are alternate interior angles. And then same with the other 2 pairs of angles. Angle 1 will be congruent to angle 5, and angle 2 will be congruent to 6. Now also notice 2, 6, they're congruent, but they're also congruent to 3 and 7. Okay? And then the other angles that are equal are 8 and 1 and 5 and 4. Okay? In a parallelogram, you've got 4 different angle measures, but here you only have 2. You have to know which ones are congruent. There's also some congruent angles in the middle where the diagonals intersect. We've got vertical angles. So 9 and 10 are going to be congruent. So I should use 3 arcs. And then, of course, the other 2 angles will be congruent, but those aren't those aren't labeled here. So 9 and 10 are congruent because they're vertical. All right, and those shouldn't equal the blue or the yellow angle. So let's go through here and see what we can figure out. All right, if angle 1 is 70, then that means angle 8 is 70, angle 5 is 70, and angle 4 is 70. Let's go ahead and add those. So this is 70, angle 4 is 70, and angle 5 is 70. Now, next to angle 1 is angle 2, and it's complementary. It's going to add to make 90 with the 70, so that's going to be 20 degrees. So angle 7 is also 20, and so are 6 and 3. So 2 is 20, 7 is already labeled 20, 6 is 20, and 3 is 20. And then we have 9 and 10, which are congruent. So the way that we want to find that is we want to remember that a triangle's angles add up to 180 degrees. So for example, if I'm looking at this triangle, I've got two angles that are both 20, and then this angle 10 that I need to find, which is going to be the remaining angle that adds to 180. So if I already have the two 20s, that's 40. So angle 10 needs to be 140 degrees, which means angle 9 is also 140 degrees. And then, of course, I could find the other missing angles right next to it because those are going to be a linear pair. So that means these two angles are both 40 degrees. And, of course, if I added this 40 with the 70 and the 70 here and here, those three angles will also add up to 180. So remember all these other properties that we've learned. All right, let's recap all of the properties of rectangle. So remember, a rectangle, it has the 5 properties of a parallelogram, which are that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, and they happen to actually be equal to 90 degrees, right? All 4 angles are 90 degrees. Diagonals bisect each other, they cut each other in half. Consecutive angles are supplementary, so if I add two 90-degree angles next to each other, that equals 180. And the one additional property is that makes a rectangle unique is that the diagonals are congruent. So that makes it special. And so not only do diagonals bisect each other, but they actually cut the diagonals into 4 congruent shorter segments. All right, bring your questions to class. See you soon.